Okay, so now that we have identified the sites, oh yeah, before I do that, I have to do the welcome speech. So hello guys, welcome to OpenFOAM. Thank you for coming to watch my video. Yeah, in the last video we are talking about how to identify sites in the blockMeshDict file, and explain to you. We go through some of the features of the blockMeshDict, and now we're going to continue to try and edit this blockMeshDict file. Now what we want to do, we'll want to let's press the insert and we'll go down. Now we will want to differentiate the left and the right side. So for starters, let's just copy this bit. Alright. Okay. Paste with the right click. Then one more. Paste with the right click. So I'm just doing it the lazy way, because I don't want to write things over and over again. So let's try and make the formatting similar at least. Alright, so I will want to change the bottom wall to just one face, right? So I want to define my bottom wall. So yeah, the context of this is that we want to change this cavity flow into a couette flow. So the bottom wall, the bottom wall should be a wall, obviously. The left and the right should be an inlet and outlet respectively. So the bottom, let's call this the bottom wall then. Let's change this into a bottom wall. Okay, so we just want the type to be a wall. That makes total sense. The face should be the bottom. Okay, so I'm just gonna delete these two sides. And now you're left with the bottom. Okay. So then I want to look at I want to make this. So now we have defined a moving wall in our boundary and then a bottom wall. So now we want the left side. So I'm going to change this to the left side. So the type, well, we can wait for it later. So let's change for the left side first. I'm going to delete the bottom and the right. Okay, well, that looks really neat. But actually you don't need to really care about the positioning of all these. Because anyway, well, OpenFOAM doesn't really care. It's just good for like what do you call that, organization, in a way that sparks joy, of course. That meme is so in, but never mind. So let's just do the same. We'll just cancel these and go to the right. We'll just use the right side. Okay. Okay. So now we have successfully redefined the bottom, the left and the right. So for now I don't want to do anything too drastic. I don't want to change anything yet, the boundary conditions. But at least we want to see if we just rename this as such, can we get the same result? So let's save this. So now all we have done is just to separate the bottom, left and right, the fixed walls, into a right wall, a left wall and a bottom wall. That's all we have done. So let's go to, let's check the names again. So we call the left side left, the right side right, and we quit. So the other place we'll need to change it is the 0 file, because these are where the boundary conditions, the initial conditions, are defined. So VIU. Okay, you can see dimensions, internal field. Don't worry about it first, but this is very important. What we are looking for, boundary field. So we see this moving wall, we don't want to touch it. We see this fixed walls, and we look at this type, and we can kind of guess, hey, this is a no slip condition. No slip means all the velocities there are 0. And if we now we look at that moving wall, okay, since for curiosity's sake, look at the moving wall, we see a type. Oh, it says a fixed value. And what does the value say? It's a uniform value with a velocity, because this is the velocity file. This is the u velocity. Okay, this is the velocity we are looking at. And then it says uniform 1, 0, 0. So it means it's going 1 in the x direction, 0 in the y, 0 in the z. Perfectly alright. So we need to change our fixed wall to like bottom wall, left side and right side. So let's do it. So we have a bottom wall. Left side. So I'm just going to type exactly. In fact, you can just copy. Why type when you can copy? And right side. Okay. Now I'm going to leave it as it is. Well, just to like demonstrate, we don't really need to care about the spacing, and we'll just churn out exactly the same result. So what we were doing just now was earlier was to edit our blockMeshDict file, which actually changes our geometry a bit. It defines the boundaries for the problem, and now this u file assigns conditions for that boundary, conditions for velocity. So no slip at the walls is quite something you're quite familiar with if we studied fluid mechanics before. No slip condition. No slip means velocity there is always 0 at any time in the problem. Okay, so we have a bottom wall, the left side and the right side, and the front and back. Now we're going to save this file. We're going to do the same for P. So we look at this, we have a similar thing, except look at this, the type here now is called 0 gradient. Do we know what that means now? Not necessarily, but what this file is telling OpenFOAM to do, it's looking for this entry called fixed walls, and then we'll assign a 0 pressure gradient to all these walls. But now that we change our blockMeshDict file, there's no more fixed walls. There's only bottom wall, left side and right side. So let's take a look and delete this. We need to tell OpenFOAM, hey, go to the bottom wall, look for the bottom wall, and we'll assign a 0 pressure gradient. So I'm going to paste twice, one here. Come on. Try again. So paste and paste. So let's do the left side. Right side. Okay, so what we've just did, we've changed the names only of the faces. We have decomposed the fixed wall condition, which has the bottom, left and right face, into one side that exclusively talks about the left, one side of the bottom, one side of the right, and we have changed the boundary conditions and the initial conditions for the U and P, the velocity and pressure. So now, if we run this file as it is, it should give us exactly the same results as the cavity file. So let's try blockMesh, OpenFOAM, So what do we have here? We have this time from 0 to 0.5, and then we have all this clock, and then let's do a touch couette.foam. Oopsie. Touch couette.foam. Look at this. We have all the same files. And let's check if it's really the same with our icofoam. So I'm going to look here. Again, I'm going to look into this couette file. Okay, let's go to desktop. Oopsie, this is my old stuff. Let's go to desktop. Let's go to this here. Look in the OpenFOAM files. We have a couette file. This is what we newly generated. And I'm going to paste it here. Okay, you see I've been doing lots of experimenting. So that's the old couette file I was working with. This is the new one. Okay, let's check ParaView. Okay, so this was the one I've already experimented with before. So I'm just going to close. I'm going to open again. Okay. Desktop. OpenFOAM files, and let's take a look at the couette. So we take a look. Oh yeah, it looks exactly the same as the original cavity file. It's exactly the same. So it means that we have coded correctly. Instead of defining the left, bottom, and right side, okay, instead of defining the left, bottom, and right side as say a file, as say a one under one name called fixed walls with these three faces, we have divided it into a left, bottom, and right side, called the left side, the right side, and the bottom wall. Okay, so now that's part one. Now we have to move on to the other part. Okay, so we're gonna close this. Okay, so now, well, I'll stop the video here. It's quite a fair bit to learn. We'll continue more in the next round, next video, where we'll talk about, we'll actually change the boundary conditions. Okay, so I'll see you next time. Bye bye. Thanks for watching.